Okay, so today we're going to start section 9, which is on one variable statistics. So this is our next to last unit. We're almost there. So today's lesson is section 9, topic 1, dot plots. This is the first half of today's lesson. And then we're also going to do topic 2 in the other assignment. So statistics is the science of collecting, organizing, and analyzing data. There are two major classifications of data. Categorical, which is categories. You've probably heard that word before. And the categories are based on qualities such as color, taste, or texture rather than measurement. And then you have quantitative, which is numerical, from the root word quantity. So if you have a quantity of something or a specific quantity, then that is referring to a number. So that is based on measurements. There are two types of quantitative data. There's discrete and continuous. These words should be familiar to you. We've talked about these in a discrete or continuous domain and range. So discrete means there's a finite number of possible data values. There's a set number. So finite, if you need to draw a word from it, line from it and write set, that would be great. There's like a definite number of data values. Continuous, there are too many possible data values, so data needs to be measured over intervals. So you have to measure it in sections. Continuous continues on, whereas discrete is certain specific numbers. So height. Height would be numerical, okay? You would measure that with inches or centimeters or whatever. And it is a continuous quantitative, okay? That is one that could go on forever and ever in theory. Now, there are only specific heights you could have, but there is a huge range of possible heights that you could have, from inches, from like just bare inches from babies to feet and so on. So then favorite subject. Well, favorite subject is non-numerical, so that would just be categorical. And then number of televisions in a household. Now, you're only going to have a set number of televisions. You're only talking about one television, two televisions, and so on. Now, part of what makes this height continuous quantitative is you can be 5.2 feet. You can be 5.3 feet. There are decimal numbers. You could be 5.25 feet. There are parts in between those numbers, in between those whole numbers that you can have. However, you cannot have 2.5 televisions, okay? You could try to cut it in half, but then it's really no longer a television. It's just a piece of a television or something like that. So discrete quantitative would mean just specific numbers. So if you were listing out the number of TVs in your house, you could say there's one TV or two TVs or three TVs. You wouldn't say 3.25 TVs. So then your area code. Your area code is a number. This is tricky. This is really tricky. Your area code is a number, but that number doesn't represent anything. That number is not a measurement, therefore it's categorical. So yes, we have the area code 662. Jackson has the area code 601, but that 662 does not reflect a measurement. Okay, it's a quality, it's a location, not a measurement. Distance a football is thrown. Let's think about this. So it's definitely numerical, that's a measurement. Could you throw a football 23.5 yards? Yes, you could. So it is continuous quantitative. You starting to see what's happening here? Okay, and then the number of siblings. Can you have, I understand that you can have, your mom might be expecting, something like that. So you could technically have, quote, a half a baby, a half-grown baby, but we only measure, we're measuring our siblings here, so our brothers or sisters. We wouldn't say we have a half a person, okay? So we have discrete quantitative, because you would have one sibling or two siblings or three siblings and so on. So then at the bottom, it says to differentiate between quantitative and categorical data, ask yourself, Can I take the average of this data, and is it meaningful? This is where that area code one or zip code or anything like that is thrown out. You could take the average of area codes, but it's not meaningful. It doesn't mean anything related to the data. If the average is meaningful, then the data is quantitative. So let's go on. A group of, let's get this in focus first. A group of college students were surveyed about the number of books they read in each month. The data set is listed below. Let's display the above data in a dot plot. So I'm hoping that you have seen dot plots before. If not, that's okay. Today's our day to catch that. So let's display this data in a dot plot. So you can see the reading frequency survey dot plot right here. Each data value is represented with a dot above the number line. The dot shows the frequency of data values. Now the frequency means the number of times something occurs. So always include the title and an appropriate scale on the number line for the dot plot. Dot plots are often used for smaller sets of data and discrete data. This is important, that we use dot plots for smaller sets of data and discrete data. So what is frequency? Frequency is how often data values occur, or the count of the data values. So it's how many times something is happening. Okay, so let's practice. The amount of time 26 students spent on their phones on a given day, rounded to the nearest hour, is recorded as follows. 0, 3, 4. This must represent, to the nearest hour, so this represents hours. Holy cow, someone spends 12 hours on their phone. That's scary. So we're going to create a data plot of the data above. Create a dot plot. So my title would be time on phone. And then I'm going to create my dot plot. So let's think about what a scale for this one could be. I really don't want to count by twos. Let's see how many I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I at least have 12. So I could count just by 0, 1, and so on. And that's going to give me more than enough room. Okay. So now I'm literally just putting a dot where there's a value. Now we kind of want to keep these dots in line so that I can measure my frequency, so that the tallest set of dots actually is the greatest frequency. So for 0, I have 1 dot. For 3, I have 1 dot. For 4, I have 2 dots. For 5, I have 2 dots. For 6, I have 3 dots. For 7, I have 1, 2, 3, 4 dots. For 8, I have 1, 2, 3, 4 dots. Remember to keep your dots in line so that you can compare them. For 9, I have 3 dots. For 10, I have 3 dots. For 11, 2 dots. And for 12, 1 dot. So then you can look at this dot plot, you can make some observations. So my mode, which you should kind of remember, mean, median, mode, and range. We're going to go back and revisit those later. But for this one, you know, your frequency, your greatest frequency is between 7 and 8 hours. You could just look at this dot plot and be able to tell that. Now, keep in mind, we use this because it is discrete data, okay? because it's rounded to the nearest hour. Now, technically, you could spend on average an hour and a half on your phone, 2.5 hours, 8.5 hours, however many hours, in portions of hours on your phone. But because this says rounded to the nearest hour, it became discrete data instead of continuous data. So let's do the try it. Ms. Ferrante surveyed her class and asked each student, how many siblings do you have? The results are displayed below. So we're going to construct a dot plot of this data. So the title could be whatever you would like it to be. Now, since she asked that how many siblings do you have, I would say the title would probably need to be number of siblings. And then we need to come up with a scale for this one. I would say my scale could just be 0 to 8. So again, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we could, just to space it out, actually, I'm just going to number it 0 to however many. I was going to skip a space, but that would kind of be weird since you can't really have a half a sibling. So again, this is discrete data here. Okay, so let's put dots. So I have 1 for 0. Let's see how many zeros I have. Let's do them all at once. So that's 1, 2, 3. Now this data the left data was in order for us over here, but this data is not, so we do have to take it piece by piece. So 0, I have 1, 2, 3, 4 ones. I have 1, 2, 3, 4, 5 2s. I have 1, 2, 3 3s. And then I have 1, 2 4s. And then I have an 8. So the 8 is out here. So what observations can you make about the shape of the distribution? Yep, there's a high frequency on 2. So most of the data is clumped together and are small in value. So most are between 0 and 4 clumped together. But 8 is far away. So then the next question says, are there any values that don't seem to fit? And yes, 8 is much higher than the others. Okay. So that 8, we'll learn in a few days, is called an outlier. You've probably already heard that before as well. Okay, so let's continue on to the Beat the Test. The cafeteria at Just Dance Academy offers items at 7 different prices. The manager recorded the price each time an item was sold in a 2-hour period and created a dot plot to display the data. Describe the data from the dot plot. So looking at this dot plot, I can make a few observations. So they sold 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So 24 items were sold. Two items for $2, or one item for $1.50, 2 items for $2, 4 items for $2.50. 1, 2, 3, 4, 5, 6, 7 items for $3. Each. And then 1, 2, 3, 4, 5 items for $3.50 each. 4 items for $4. And then 1 item for $4.50. So that's my data. Now you could also kind of generalize here that the average, most of the items sold were in that average price range. Very few cheap items were sold and few expensive items were sold, but the most items sold were averaged price. Okay, so now you're going to look below this video and you're going to complete the 5 practice questions. Then you're going to move on to topic 2, which is histograms.